So for the digital SAT, the College Board is introducing new types of questions left and right. And if you only saw this question on the paper SAT, you'll definitely see a variation of this question on the digital SAT. But the problem is that no SAT book is talking about this. And the question is, will you know how to solve both of them when they show up on your next SAT? Because they are going to show up and you simply have to know this small difference on how to approach them differently. And this is a quick summary I have put together after 11 years of tutoring and analyzing 5,000 official SAT questions. So sit back, relax, learn the differences, and let's get a higher score on your next SAT. So guys, we're going to start off with the quick summary of the basics, and we're going to dive into the specifics you need to know for the SAT. And as always, everything we go over in this video is going to be nicely organized into a PDF, which you can download and print out and try with me because that's how you get better. I'm going to link it in the description box down below. So let's get started. What makes two triangles similar versus congruent, right? So these two triangles are considered congruent because they are the same triangle. You see, the word congruent is just another fancy word for same or identical. And two triangles are considered congruent triangles when they have one, same set of angles, and two, same set of side length. If you look at two triangles over here, they have same angles for 60, and they have 8, 8, 8, 8, 8, 8 that have same set of side length, okay? When these two conditions are met, they are literally identical triangles, right? And that's why we call them the same triangles or congruent triangles for the SAT. But what if two triangles are kind of same, but they're actually not the same? Well, here's the thing. Let's look at two of these triangles right here. They have same set of angle. They have 60, 60, 60, 60, 60, 60. Their angles are the same. But their side length is 4, 4, 4, and 8, 8, 8. They have same set of angles, so their shape kind of looks similar, but they're not the identical same triangles. Instead, their side length are just proportional. 4 and 8 times 2 times 2 and times 2 all around the triangle. If two triangles kind of look the same because they have same set of angles, but they are actually different triangles because they have different side length, one's bigger than the other, that's what we call similar triangles. It has same set of angles, but the side length are going to be different. They are just going to be proportional. So that's going to be the basics. Let's go deeper into what you need to know for the SAT. So when it comes to similar triangles, I'm just going to give you guys a quick summary because I went in depth on this concept in this video right here. I'm going to link it in the comment section down below. But two triangles are considered similar when their side length are proportional and they have same set of angles. So if we look over here, we see that, okay, they have 60, 60, 70, 70, and 50, 50. Okay, they have same set of angles, but their side length are going to be proportional. 4 and 8 times 2, 6, 12, 5, 10. They're going to be not the same, but they're just going to be proportional. And for the SAT, when it comes to medium difficulty similar triangle questions, they're going to ask you, hey, you're given these two triangles, are they similar or not? They're going to ask you to prove whether these two triangles are similar or not. And for you to prove that, you just have to check whether they have same set of angles or same set of side length. And the key point here is that you only need to know one or the other. You don't have to know both to prove similarity. So for example, let's say you're given these two triangles over here and you're not given the angles, but just the side length like so. Then you can look at the side length and say, oh, 4 and 8, that's going to be times 2. 6 and 12, that's times 2. 5 and 10, that's times 2. And because all of your side length are going to be proportional, that is enough to prove similarity. And it also goes the other way for angles as well. Let's say you're only given angles like so. You see that you only have 60, 60, 70, 70, 50, and 50. You see that you have same set of angles, which is enough to prove that these two triangles are considered similar. So for the SAT, when it comes to similar triangles, you just simply have to check whether they have same set of angles or same set of side length, because that's the main thing they're going to test you on. And when it comes to not medium difficulty, but the hard difficulty question, they are simply going to twist off of this main idea of whether these two triangles are similar or not. So this is the very basic thing you need to know for similar triangles for the SAT. And we're going to go over how SAT twists up these concepts for harder questions in later videos. But first, here is a quick question on how a question will actually look like on the SAT. So the question says, in triangle ABC and DEF, angles A and D each have 42, and their side length AB is that and DE is that. Which additional piece of information is sufficient to prove that two triangles are considered similar? And we have learned that to prove similarity, we just have to check whether they have same set of angles or they have same proportional side length. So as always, when it comes to geometry questions, we're always going to visualize out what the question tells us. A, B, C, D, E, F. It doesn't have to be perfect. It's going to be 42 here. D is going to be 42 here. And AB is 11. And DE is going to be 22. So if that's 8, that's 16. Is that enough to prove similarity? Well, with that information, we only know 2 of the 3 side lengths for both triangles. And we can't find out what the third missing side is because we don't know if this is a right triangle, which means we can't use Pythagorean and we can't use SOHCAHTOA. For you to use Pythagorean or SOHCAHTOA for the SAT, it has to be a right triangle. I'll link a triangle lecture in the pinned comment down below. So choice A is going to be out. Let's look at choice B. Angle B is 50 and 72. So it's going to be 50 here and F is going to be 72, which means the third missing side is going to be 88 over here and that's going to be 66. And because they don't have same set of angles, it's not sufficient to prove that these 2 triangles are similar. Let's try out the third choice. Angle B is 50 and 88. So 50 and 88, which means that side is going to be 88 and that angle is going to be 50. They have same set of angles, which means 2 triangles are going to be similar. So next, let's go over the congruent triangles. As we mentioned previously, congruent just means identical and they have to have same set of side length and same set of angles. And unlike the similar triangle where you have to have only one or the other, when it comes to congruent triangles, you have to have both. You have same set of angles and same set of side length. So that's the basic definition. But for the SAT, they're going to test you on your ability to prove whether 2 triangles are congruent or not. And for 2 triangles to be congruent, it has to meet one of these 4 conditions. SAS means side, angle, side, angle, side, angle, 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 side, 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 side. You probably have heard of this at some point, and these 4 things are, in a way, formulas to prove whether 2 triangles are identical, whether these 2 triangles are congruent or not. And here's how it works. Let's look at number 12. The question says, in triangles ABC and DEF, if angles A and D measure 42 and D's measure 22, which additional piece of information is sufficient to determine whether the 2 triangles are congruent or not? And as always, you want to visualize out what the question is telling you. We have AD is 42, so 42, 42 here, and ABDE is 22 and 22. And let's look at choice A, length of CB and EF. So let's say we know this as like 5, and EF is also 5. And if you look at what you have, you only have angle, side, and side. You have angle, side, side, you have angle, side, side, angle, side, side. And that is not family friendly. So if it's not family friendly, it's not enough to prove congruency. College Board is a family friendly company, and when they see this, it's not going to be the answer. It has to satisfy one of the 4 things shown up over here. That's why choice A is not going to work. Let's look at choice B. Let's say you know the measure of angle B over here, okay? So let's say this was like 30 degrees. Then you have angle, side, angle. You have angle, side, angle. And that is one of them, right? So B has to be the answer, right? Well, here's the thing. When it comes to proving congruency, you have to make sure that you can prove the condition for both of the triangles. And the condition was angle, side, angle. We have to know angle, side, angle for this triangle and also the next triangle. But for the second one, we only know angle, side, and we don't know what the third one is. And as a result, that's not enough to prove congruency. So choice B is going to be out. But what about choice C? The measure of angle B and E, right? So we got B over here and we got 30 as E over here. Now we have angle, side, angle, angle, side, angle, which means that's enough to prove congruency for both triangles. So our answer is going to be choice C. So if you understood the definition and the difference between similar and congruent triangles, and you understand inside out for both of these triangles, then let's move on to some medium difficulty question. I'm going to link in the pinned comment down below. It's going to be the next video. So that's going to be it. I'll see you guys on the next one.